Hello and welcome to Module 6 in our C language series. Today's session is going to focus on functions. Let's start with the general form of a function, and this would be something like this, where the type specifier would indicate the type of value returned by the function. This could be integer, character, float, or even void, which would mean no value returned by the function. Now, if we do not include the type specifier in the statement, the compiler will assume that an integer is returned by the function. Coming to the parameter list, this would be a comma-separated list of variables along with their data types. These parameters would get their values through the values of arguments in the calling function. Now, a little more about parameters and arguments later. We need to talk about scope rules first. So what exactly are scope rules? Scope rules are rules defined by the language itself, which determine whether the code and variables inside a function can be accessed outside a function as well. In C, every function is a discrete block of code, and so code and variables are private to each function, unless, of course, there are global variables, in which case those are available to all functions. If we talk about local variables, we know from a previous session that these variables are created when the function is called, and then of course they are destroyed when the function finishes execution. In this process, of course, their values are lost unless, of course, we declare these variables using the static storage specifier, in which case the values will be preserved between function calls. Again, we've seen this in an earlier session. Now coming to function arguments, these are used to call functions. Their type needs to be the same as the parameters to the function. But C, being a robust language, a syntactically correct program will run despite any mismatch in terms of data type between parameters and arguments. Now we're going to go ahead and write some code, and you need not write this. This is just for demonstration to give you a clearer understanding of parameters and arguments. Let's just call this params and args. So hashtag include stdio.h. Now, when we are going to have a function other than main, we need to declare that function outside main. And so we say here int calc netsal, that's the name of the function. Note that it's going to return an integer, that's our type specifier. Within that, we specify the parameter. This is going to be of integer type and it's going to be called sal. Now we can start with main. And of course, we need variables. This program is just calculating net salary, but of course, it's going to be using this function to do that. So int salary, which we will get as input, comma net salary, which we can use to store the return value of this function. Printf, enter salary, and then scanf, %d, comma, ampersand sal, or salary rather. Right, that's the name of the variable. Right, and now what we need to do is we need to call the function. Two ways of doing that. One is to use net salary on the left hand side, which will then catch the return value of the call to the function calc netsal. We need to specify the argument within brackets there, and that's going to be salary. Remember, main is the calling function, salary is the argument. Once we have net salary, then of course we can go ahead and print it out. There's another way to call the function from within the printf statement itself, and we can say printf, the net salary is %d, and then after the comma we can call the function and again send in the argument salary. Right, so these are two ways. I'm going to comment out this one. You can try that later after the session. I'm just going to use a printf statement. Right, so now we are done with defining main. We need to now define calc.net_sal. And here within brackets, because this is a called function, what we're going to put in there is going to be called the parameter. So int sal, remember it needs its data type. Within this function, we will just calculate net salary. So sal minus equal to, and this would be sal multiplied by 0.2, deducting 20% tax. Now what's important to remember is we don't need to keep the name the same. We can call the sal1, right, and change this as well, and this as well, and that's fine. Of course, the data type has to remain the same. Now we need to return sal1. Right, so when we return sal1, what happens is, if for example you're following this method, the return value will be caught in net salary as I mentioned earlier. Otherwise, it will just be printed out here. So let's run this now. Enter salary, let's say 4,000, and you can see the net salary is 3,200. Right, it's printed out there. Moving on, types of function calls. We have call by value and we have call by reference. Let's take each of these separately. In a call by value, the copy of the value of the argument is put into the formal parameter of the function. The changes made to the parameter in the called function do not affect the argument value. So the argument value is going to stay the same. Let's go back to our code. And we will observe now that this is an example of call by value. How do we know? What we can do is in this printf statement, we can just say with gross salary %d, and here we can print out the value of salary. Remember, salary is the argument going to calc.net_sal, and of course we are recalculating it here. But because just a copy is going to be put into the parameter, salary will retain its value. So if I run this now and you enter 4,000, you can see net salary is 3,200 with gross salary 4,000. Right, so this is an example of call by value. Now moving on, call by reference. Here the address is copied into the formal parameter. Right, so instead of the value of the argument, the address is copied, and therefore changes made to the parameter in the called function will also change the argument values. What's important to remember is that it's call by value that is mostly used with a few exceptions, and this is to ensure that the variables in terms of their values are not altered. But we'll see how to force a call by reference in the next slide. Now coming to how to create a call by reference. And as we saw earlier, by convention, parameters are passed by value in C. Passing a pointer to the argument will create a call by reference, and we'll see how shortly. Functions using pointer parameters must be called with the addresses of the arguments. That's pretty clear. Pointers provide a fast means of referencing array elements. We know that, right? And therefore, when we are sending arrays to functions, we need to use call by reference. Call by reference allows functions to modify argument values. So now I'm going to show you a demonstration of this. And again, you don't need to write this code. This is just going to be a simple program that is going to have a function that calculates the cube of a number, stdr.h, and now of course we need to declare the function that we're going to define later on. Right, so this is going to be int cube, type specifiers of integer. We have int num as the parameter. Int main Within this function, we will have int num, and I'm going to have that as a constant 10. Printf cube of %d is %d, comma, here we'll have num, and we'll call the function cube with num as argument. That completes main, and now we define cube. So int cube, and again we need to specify the parameter there, so int num. Within this function, all we need to do is say num equal to num into num into num. Right? We're not using power, of course, because we're writing our own function to find the cube of a number. Cube of 10 is 1000, right? So this works pretty well. You're just returning this particular value, and you can have a return statement. Note that if I don't put it, that value is still printed out here, right? But it's good to specify a return statement just to sort of be clearer in terms of your code. This is, as you may have figured out, a call by value. How do we make this a call by reference? So I'm going to comment this out now, and we'll start with call by reference. I'm going to put in a comment here. So here we'll have void. So the function is returning nothing, cube, and it's going to take an int, but it's going to be a pointer to integer num. Int main, and within this, again we say int num equal to 10, and we'll have a pointer there. We'll initialize this pointer to the address of num. Hope you're with me so far. Now we'll call the function with pointer, right? And then we'll print f cube of %d is %d, and then we'll have comma num comma star ptr, right? That completes main. Now to define the cube function, cube, and that's going to take a parameter int star num. Within this function, all we need to do is we can just say star num equal to star num into star num into star num. So now if I run this, you can see that the argument value has also been changed, right? Num has now become 1000. How do we get the value printed as 10 here? What we can do is we can introduce another variable. Let's call it temp. We can assign to temp the value of num. Remember, temp has a different address, and therefore when we print out temp here, it's going to print 10 instead of printing 1000. So now if I run this, right? I hope you got how call by reference works. Now moving on, calling functions with arrays. When an array is used as an argument, only the address of the array is passed, not a copy of the entire array. This is important to remember. It's just the address of the array. We know that the address of the array is normally the address of the starting element, right? An array name as parameter passes a pointer to the first element in the array. Parameter declaration must be of compatible pointer type. So again, the argument and the parameter must have the same kind of pointer type. The actual contents of the array are altered, obviously, because we're sending in the address. There are 3 ways to declare a parameter that will receive an array pointer. So now let's look at those 3 ways. I'm going to go back and write some new code. These programs will be available at a link in the description. We'll have different functions, right, with the different ways of specifying the parameters. So dispnum will take the parameter in this form, which will be int num10, and you can see that's a full description of an array. There'll be another function which we will call shownum, which will take the parameter again of integer type, but it will be num with no size. So that's another way of specifying array as a parameter. And the third will be using a pointer. So I'm just going to call that use ptr. And again, that's going to be int, but it's going to be star num. Right? Now, our main function is going to do nothing but just, first of all, declare the array, so numbers, and that's going to have 10 elements. We're going to have an index. We're just going to use index as a counter to place numbers into this array. So for index equal to 0, index less than 10, plus plus index. Within this loop, all we say is numbers of index equal to, and because index is 0 for the first time, we'll just say index plus 1 so that we can start from 1. Right? So there's only one statement for the for loop. Outside the for loop, we'll have numbers of index equal to 0, indicating the end of that array. Now we'll call these functions to display the numbers we have in the array. So this num, that's going to again take the argument, which is going to be numbers. We'll call show num with numbers as argument, and we'll call use ptr with numbers as argument. To sort of have it neatly printed out, you can put in a \n there, and again here. Right, so this completes main. Now what we do is we define our dispnum. And again, this is going to have as parameter int numbers, and that's going to be 10. Right, just as we had specified here. Of course, I've just changed the name. So within this function, what do we do? We'll just have int star I. What's important to remember here is that although we have the parameter declared as a full integer array of 10 elements, the compiler is automatically going to convert this to an integer pointer. And we can say I equal to numbers. And then we can say here, while star I. You know what this means? While the contents at I are not equal to null. What do we do within this? We just printf %d, comma, star I plus plus. That's all. Right? Now we define our next function, void showNum. Now this one has the parameter specified as int numbers with no size. And this is allowed because the size is irrelevant to this function. Why? Because anyway in the program we have the size. So remember, size needs to be specified in the program. It is irrelevant to the called function. And within this again, we can have int star I, and then I equal to numbers, and then while star I. And what do we do here? We just printf %d, comma, star I plus plus. Right? That completes showNum. And then we have void use ptr. And this is going to take a pointer to the argument. So int star ptr. And within this function, all we'll say is while star ptr printf %d, comma, star ptr plus plus. Now this is the most efficient, the most professional, and the most easy to read method of specifying the parameter, and of course writing this code as well. Note that we also have reduced one line of code, or rather 2 lines of code, right? So now if we run these, they should give us the same results, all of them. Okay, it says implicit declaration of printf, which we deal with later, but you can see that the results are the same. Right, so printf, why? Because we've forgotten to include stdio.h. Right, so now that shouldn't give us that warning. And there we have it. So you see the results are the same as I said earlier. Moving on. Now we will write some code, and this you can write with me. Write a function that takes a string and converts all characters to uppercase. In effect, what we're going to do is we're going to be using what is called the ASCII table. If you look here, you can see if we have lowercase characters, right, all of them start from decimal 97 and end at 122. You can see Z is 122. And if we've got to convert them to uppercase, from 97, for example, if we subtract 32, we will get 65, and you can see 65 is uppercase A. Right? So 32 subtracted from any lowercase letter or character, alphabetic that is, that will give us the uppercase equivalent. So let's go ahead and write that code. Now you can start code blocks and start a new file. Right, so hashtag include stdio.h, and then we start with declaring the function that is going to change the case. So change to upper, and that's going to take a pointer str2. That's going to be a pointer to a string, right? And then int main. Within int main, we'll declare our character array str1 of 80, which is going to accommodate the string, of course. And then printf, enter a string. And then scanf, percentage s, comma, str1. Right, I hope you're with me so far. Now we call the function change to upper using str1 as the argument. And then of course we can just printf percentage s, comma, str1, which by the way will change after the execution of this function to uppercase, right? Why? Because we're using call by reference. Remember, that's a pointer. So now we'll have our function char change to upper, and we'll have char star str2. Within this function, let's have a char star ptr and then initialize that to str2. And then while star ptr, here we say if star ptr greater than equal to 97 and star ptr less than equal to 122. Then what do? We will say star ptr equal to, or rather minus equal to 32. So we're just subtracting 32 from the value to give us the uppercase equivalent. Right? And then of course we need to move the pointer, so ptr plus plus. So now let's run this. Enter a string, let's say apples, and you can see that's printed out in uppercase. Right, moving on to the next program, write a function that works similar to getS in C. Now, I haven't really gone into getS because it's been deprecated. Why it's been deprecated, let me show you, and you will also see how that works. So you can just start a new file. So hashtag include stdio.h and then int main. We're just seeing how getS works. Within main, you don't need to type this part, right? Just watch how getS works. So if I say, for example, printf, enter a string, then I can say getS, and of course I need a variable there. So I'll have a character str1, let's say, of 30 elements, for example, and getS str1, right? Then I can just printf str1. So that would be percentage s, comma, str1. Right, so let's run this. Now you can see that I have process return negative something. This indicates that I have written in a place in memory that I'm not supposed to write in, and that's because the length of my string has overshot, of course, the 30 elements, right, leading to what is called buffer overflow, and therefore it's been deprecated. But now we're going to write our own, right? So we start with char str1. We'll have this as 80 characters, and then we'll have printf enter a string, and we'll call our own function. Let's call it myGetS str1. We've got to declare this function here, so char myGetS, and that's going to take a character pointer. Now here we start the definition of our getS function. So char my getS char star str2. Within this function, we'll have int x char ch so that we can get one character at a time, and we'll also have a pointer star p equal to str2. Right, now we'll have our for loop for x equal to 0, x less than 80, x plus plus. And here we'll have ch equal to get char, and then switch ch. We need to check whether the character entered is a return character or a backspace character, right? And accordingly take appropriate action. So we'll check now if it is the \n, right, or the new line character. So case \n, and remember to indent this. In case the character is \n, we'll say str2 of x equal to \0, signifying the end of string, and then break. Case \b, which is backspace, then we can say if x is greater than 0, right, because we cannot move backspace if it's the first character in the string, right? We can only move backspace if it is greater than the first character or further than the first character in the string. So greater than 0, then what do? We say x minus minus and break, right? Case, or rather default, then what do? We will just assign to str2 of x the value of ch, right? So when the break is encountered, control will come out here, and we say if str2 of x is equal to \0, right, then what do? Return p, else we just continue in the for loop. I hope this is clear. We're getting in one character, checking if that character is any of these, right, assigning values accordingly, and returning the string if str2 of x is \0. Otherwise we continue in the loop as long as x is less than 80, right? Now let's run this. Okay, we haven't put a semicolon there. There needs to be a semicolon there, and returning character star from a function with return type character makes it. So which line is this? This is line 32. So this is happening where we are returning p. Why is this happening? When we are declaring this function, remember, we are returning p, which is a pointer, right? But our function is not stating as such. So what do we need to do? We need to specify that this function is returning a pointer. We just do that by putting in a star there. Now we shouldn't have that warning. So enter a string Well, it works, right? So this is an example of how we can rewrite C functions. Okay, we've just rewritten getS. Now moving on. Arguments to main. Now the main function also can take arguments. They're called command line arguments. They are argc and argv. Argument C contains a number of arguments. Now by default, the count of arguments in argc would be 1, which is for the program name itself. Argv is a pointer to an array of character pointers. This too will have one element, which is again the program name. Each element in the array points to a command line argument, and as I said, the first element is the program name. Important to remember that all command line arguments are strings. So if you want a number, then within your function, you would need to convert that to an integer. Write code to accept user's name on the command line and print the message, hello user name. So again, you can write this with me, and I suggest you do that. We start a new file. Of course, we start with hashtag include stdio.h. We need also include stdlib.h because we're using argc and argv. Int main. Now this is int argc char star argv. Remember, it's a pointer to an array of character pointers. Okay. Within this, we'll check if argc not equal to 2, right? Because we want the user to enter their name. So if there's just one argument, it means that's just the program name, and we need 2 arguments here. So if argc not equal to 2, then what we'll do is we'll printf you forgot to enter your name exiting. And then we can actually use exit 1. Now, of course, we need a code block because that's 2 statements. So just put that in. Right? Otherwise, what we'll do here is we just printf hello %s comma argv of 1, right? Because argv0 is a program name, so argv1 would be the user's name. Right? Let's run this. But how do we run it? Because if we run it like this, okay, there's a semicolon missing somewhere, that's here. So if we run it like this, you can see there's no waiting for us to enter anything. So for programs that are accepting command line arguments, you can just click the build button, right? That will just compile, and then we need to run them from the command prompt, which means you need to go to command prompt here in your search bar, open it, and go to the directory in which the program is. So mine is in OneDrive. Go to wherever your program is. And then, of course, run the program. It's called greeting. And you can put in your name. And there you have hello, Andy. Right? If I don't put in a name, then I'll get the message. Right? And of course, the program ends. Okay, so that's one example of command line arguments. Write code to accept a number on the command line and have a countdown with beep at the end. Right, so the user enters a number, we count down, right, from that number to 0, and then have a beep play at the end. So let's go back to code blocks. And let's write that program. So again, new file. And let's start with hashtag include stdio.h and then hashtag include stdlib.h. Now, because we're going to be accepting a number at the command line, or at the command prompt, I should say, we need to convert that to an integer. For that, we can use a header file called ctype.h. Int main, and of course we need to specify int argc, comma, char star argv. And within this function, we'll have integers disp and count, and you'll see why we need those shortly. If argc less than 2, then what do? We need to printf you must specify the length for countdown exiting, and then exit 1, and that's it. Now we check if argc is equal to 3 and not strcmp argv of 2, comma, display. So what we are saying through this is we are checking whether the third argument in this array is equal to the string display. If it is, then what do? We say display equal to 1, else display equal to 0. So now we'll implement the countdown. We say for count equal to, and remember this count is being specified as a number, of course, at the command prompt, but remember all command line arguments of string type, we need to convert it to an integer. So we use a to I or ASCII to integer, which comes from ctype.h. So a to I of arg v of 1. Our condition is count is not equal to 0. So just count there and then count minus minus. Right, so now you know why we need these two integers. Within this loop, we say if disp, which means if display is not equal to 0, then we need to print out the numbers as we count down, right? So printf %d \n, comma, count, and that's all. Once we are out of the for loop, we need to have a beep sound. So put char 7. 7 is a character that will sound a bell in almost any language, I will say. Put char 7 and printf done. So now let's run this. Okay, we have an implicit declaration of function strcmp. What do? We just import string.h. Now, of course, this is not going to run here, as I said, because this requires command line arguments, right? So you can just build instead of build and run. And then, of course, go back to command prompt. Again, change directory, right? And then now we can run it. Count down. Let's say 10. Now I didn't specify display, so the numbers are not printed out. Press the up arrow on your keyboard to go back to the same command and type in display there, and you'll have the numbers printed out. Now, what if I wanted a delay after each number is printed out? So here I can see sleep 1000. This is in milliseconds. I'm using Windows, remember, and I need to include windows.h. Right, so this is going to then delay or provide a delay for 1 second. Right, so let's run this now. We need to go back to the command prompt. And now, of course, count down. 20, display. And now you can see we have a second delay there. Right? Okay, so I'm going to shut this down now. Let's move on. The return statement causes an immediate exit from the function. May be used to return a value. And there are two ways that a function terminates and returns to the caller. One is without specifying the return, like we saw earlier, and one is we use the return, but it's recommended to use that return statement. Right? Returning values. All functions except those of type void return a value. This value is explicitly specified by the return statement, as we know. If no return statement is specified, then generally C compilers will return 0, but this is not to be taken for granted. What's important is that every function except those that are declared void can be used as an operand, therefore, in any valid C expression, because we have return values, and we've seen how this is done earlier, right? Now again, write some code. Write a function to reverse a string. It should be called from me. We're going to go back to code blocks, start a new file. So now here we have hashtag include stdio.h and hashtag include string.h, because we're going to be using strlen. So we have our function, which is going to be void string reverse char star s is going to be the parameter. Int main. So here we'll have string reverse. I'm going to pass in a constant string there, call it hello. Then printf \n and printf done. Right? That's all for main. Define string reverse, so void string reverse, and that's going to bring in the parameter char star s. Right? Now within this function, we'll have int counter and then for ctr equal to strlen of s, right, this particular pointer, comma, or rather semicolon, ctr greater than or equal to 0, and then ctr minus minus. And then we're just going to put char and s of ctr, right? Return. But do we need a return? Let's see. Right, let's run this. And you can see that's printed in reverse and our message done is printed out without the return. But as I said, it's important to have a return statement. Right, and that would give us the same result. Okay, so moving on now to the next program we need to write a function to find a matching character in a string. So let's go back to code blocks and start a new file. Right, hashtag include stdio.h and declare our function. So star match, that's going to return a pointer and it's going to take as parameters char c and char star str2. Now we're going to have our main function, and within that what we'll do is we'll have our array. So str1 of 80 comma star ptr comma ch. Printf, enter a string, right, and scanf. Now because a string could be many characters long, we will use percentage and then specify that until the new line character is encountered, we need to continue accepting input, right, comma str1. Okay, and then what we need to do is ask for the character to search for. So printf, enter character to search for. And here we will use get char. So ch equal to get char. Right? Once we have that character, we can say ptr equal to match, send in ch, that's the character to search for, as well as the string, right, or the array. Then we check if star ptr. What does this mean? If it's not equal to null, then what we can say is printf %c found in %s, and then we can have ch comma str1, right? Or we could say star ptr, right? Else printf %c not found in %s comma, okay, let me just put in star ptr, and then we can change that later because you'll see what this prints out. Right, now we define our function match. So char star match, which is of course taking in parameters char c comma char star str_2. Within this function, what do? We say while star str_2 not equal to c, and we need to make sure that we're not overshooting the end of the string. So and star str_2, which means that's not equal to null, right? What we do within this is just str underscore 2 plus plus. And then of course we return str underscore 2. So now let's run this. Enter a string. Let's just say here, apples are good. Now you see enter character to search for did not wait for me to type in anything, and that's because we need to include the f flush. So f flush stdin, and we need to include it after scanf as well. Whenever you're using getChar, right, you need to include this. Run. Apples are good for health. Let's say Z. Now you can see this is not printing out the Z, but it's telling us it's not found in apples are good for health. Why is it not printing it out? Because we're saying star PTR here. And remember, star PTR is now a null because it's not found. And so we can change this to CH. Now if we run it, apples are good for health. Enter a character Z, Z not found. Try it with the character that's there in the string. Just going to say apples now and look for A. A is found in apples. Right, so moving on. Functions as operands. Continuing our discussion on that. Are these statements valid? The first one, yes. Right, we can have a y receiving the result or the return value of getSum. What about this one? If max x of y greater than 100, printf greater. That's also valid. What about this one? For ch equal to getChar is digit of ch. That's also valid. But what about this one? We cannot have a function on the assignment side of the statement, and therefore this is not allowed or invalid. Moving on, write code to check if a character input is a letter of the alphabet or not. So going back now to code blocks, write some more code, start a new file, and hashtag include stdio.h, and then int is alpha, that's going to be our function. It's going to take in a character C. Okay, that's just a parameter there. And now int main. And within this, we'll have char ch. Printf, enter any character, and then ch equal to getChar. Let's use the f flush stdin. If is alpha, so we're using the function as an operand, passing in ch, right? Then printf %c is a letter in the alphabet, else printf %c is not a letter of the alphabet. That's all in main. Now we write our function int is alpha. It's returning an integer, taking in a character as parameter. Within the function, what do we check? We know from the ASCII table, so we can check if C is greater than equal to 65 and C less than equal to 90, right? Those are uppercase. Or, and so we'll need another bracket here, or C greater than equal to 97 and C less than equal to 122, right? Then what this means is it is a character in the alphabet, so we return 1, else we return 0, right? So when this return happens, remember we are checking here is alpha CH. So if it's not equal to 0, then we know this is a letter in the alphabet, because remember we are returning 1 if it meets this condition. If it is a 0, it will say that the character is not a letter of the alphabet. Let's run this. Enter any character, let's say F. F is a letter in the alphabet, but it's not printing out our character because, of course, we haven't specified it here. So, comma, CH, and again, comma, CH. Try that again. G. G is a letter in the alphabet. Try a number, let's say 4. 4 is not a letter of the alphabet. What if I try a double-digit number, 10? 1 is not a letter of the alphabet. What happened to the 0? Remember that C is of character type, so it takes only 1 byte. Right, moving on. Write your own strlen function. I'm going to leave this with you, and I'll give you the solution in the next session. Function types. They could be computational, calculating square root or sine. They could be functions that manipulate information, like fclose, which is, as we'll see in a later session, the function to close the file. This will return a 0 or a 1 depending on success or failure of the fclose. Then we have no explicit return value, right? That's also a function type. It's a void type that returns no value whatsoever. Does a value returned by a function have to be assigned to a variable? No. Remember, we have int main, and we do not assign that to any variable, so that's not necessary. Returning pointers are pointers to variables, integers or unsigned integers. The answer is they are neither of them, because they are memory addresses of a certain type of data. And we've seen this when we talked about pointers. Pointers returned, therefore, must be of the same data type as the parameter. Functions of type void, we know, do not return values. Important that it prevents their use, that is, the use of the values in any expression, and helps avoid accidental misuse. So you will use void when we don't want a value to be returned and then misused or accidentally used. What does main return? Returns an integer to the calling process. But what is the calling process? That's the operating system. Returning a value from main is the same as calling exit. Therefore, we have 0 when our main function runs successfully, and we have a different value if it is not successful. Some compilers may issue a warning if function is not declared as void and also does not return a value. But the compiler we are working on gives us a warning if we do not declare main as returning an integer type. Coming now to recursion. What makes recursion possible? It's because functions can call themselves. But when is a function recursive? It's when there is a statement within the body of the function that is calling that function. And because the function is calling itself, recursion is also known as circular definition. The best way to understand recursion is to code. So we're going to write code to find the factorial of a number first without recursion and then using recursion. So let's now go back to code blocks and start a new file. Hashtag include stdio.h. We need to declare the function, so int and then fact. The parameter is going to be of int type num. Now int main. Within main we need some variables. That's going to be int num comma f. And here we say printf, enter a number, and then scanf %d comma ampersand num. You can then use f to hold the return value of the function, calling the function now with the argument num. And then we can print the factorial of %d is %d comma num comma f. Hope everything's clear so far. Now we define our function fact. Parameter is num. You can call it num1 as well. Within this function, we'll need a variable counter, because remember, factorial is something like this: 5 into 4 into 3 into 2 into 1. Right? And so counter will be used to count down. We'll have that in a loop for counter equal to num minus 1. Counter needs to be greater than 0 to stay in the loop and decremented each time the loop is executed. Within this loop, all we say is num equal to num into counter. So the first time it will be 5 into 4, then that will be this whatever's in num into 3, into 2, into 1, etc. And then of course we'll return num. Right, let's run this now. We enter 5 and you have the factorial of 5. Now this is without recursion. As I said, to introduce recursion, you just comment out this block of code and start a new block. So I'm going to copy this part because that's the same. Control C, you just put it down here. Now we have the parameter num, that's the same. And within this function, all we say is if num equal to 1, return 1, else, and this is where we're using recursion, return num into fact with num minus 1. So the first time num is 5, right? So it's going to come to this statement, and then it's going to call the function again with num minus 1, which is 4, right? And then when it's 4, it's going to come back here again. It's going to call fact again with 4 minus 1 is 3, and so on, right? Let's now run this. And we'll enter 5 again, and you see the factorial of 5 is 120. Continuing with our discussion on recursion, which do you think is faster? In actual fact, recursion is a bit slower. Why? Because there are so many function calls involved, right? But of course, we'll see why we are using it. Moving on, what happens behind the scenes when a function calls itself? So the first time we saw the value was 5, so that is put onto the stack. We are now pushing onto the stack. Next time fact is called with 4. The next time it's called with 3. The next time with 2. And then we have num as 1. Now we're going to be popping off the stack. So 1 will be popped off first. So that'll be 1 into 2 next, 1 into 2 into 3, 1 into 2 into 3 into 4, and then 1 into 2 into 3 into 4 into 5. And that's how we have the factorial, right? Recursive calls do not make a new copy of the entire function. It's just arguments that are new. That's important to note. Now, does recursion reduce code size? Not significantly, a little bit, yes. Does it improve memory utilization? Again, not significantly. So why is recursion used then? It's because it allows for clearer and simpler versions of algorithms. And we'll see this later when we talk about different types of sorts like merge sort, quick sort, etc. This would be for later sessions. Now coming to declaring variable length and type parameter list. Functions can have a variable number and type of parameters. The declaration would be something like this, ending in 3 dots. We're not going to be doing this today. This is again for future sessions. What's important is that the function must have at least one argument, right? To use those 3 dots. Now, what we've been doing so far is adopting the modern prototype for declaring functions, which is this, right? But of course, you will see a lot of code using the classic type. It's not recommended though, because if you think about it, we're not mentioning the type. It's very difficult then to match arguments and parameters, right? It's not as clear. This is clearer and therefore is recommended. Coming to implementation issues with regard to functions, parameter and general purpose functions. What is a general purpose function? Something that's going to be used by another programmer. And if you want your function to be used by other programmers, it's recommended not to use global variables, but rather to send information to the function through parameters. This keeps your code more readable and less susceptible to bugs. Efficiency. So when we are calling functions, we know that there is a slight time lag, but that's very slight. But if that slight time lag matters in terms of speed of execution, then it's recommended to have what is called inline code. In simple terms, put all your code into main function. Libraries and files. Now, when we write a function, we can choose to do 1, keep it along with main in the file, move it to a separate file with other functions, or place it into a library. Coming to separate files, this would be when you have large projects like writing an editor. You may have functions that, for example, deal with deletion of text or searching of text or addition of text. You would club functions into one file, which would make it easier to access rather than looking for where you place that particular function. Libraries. Every compiler provides guidelines on how to create libraries, but when would you use a library or when would you create a library? Let's say you wanted to club all statistical functions together without having to bring the whole lot into your program, right? You could then choose to place those into a library. How big should a program be? There's no real rule for that, except that we need to keep our code modular with each function executing one task, right? So that makes your code easier to read and also easier to debug. This ends our session for today. In the next session, we'll be talking about structures and unions. Till then, take care, stay safe. Bye.